The following video documents the progression of a new type of knowledge system being developed at the National Archives in the UK, TNA, which has replaced its existing administrative database. The TNA Collection Care Department comprises a team of experts who can serve the UK's National Archives, continually generating knowledge from their everyday work. This knowledge is not simply about the materiality of the collection. In order to conserve effectively, contextual knowledge is required to inform the right choices. And like other cultural heritage experts, understanding the history of something is crucially important. Using an ongoing project, the scientific analysis of textiles found in a wallet of a Dutch trader, which was seized by the British Admiralty in the early 19th century, this video shows how semantic networks can be used to build knowledge which has a greater value both inside and outside the organisation. Knowledge maps use a semantic ontological framework that allows subject experts to model data according to the individual needs of a particular piece of work, yet with all the advantages of structured data. This means better integration and collaboration on information and improved decision making. It also improves the educational and engagement value of information produced on a daily basis. The project involves the scientific analysis of various textiles to understand the techniques and processes within the context of a trading network between the East and the West, with a view to contributing to the understanding of trading relations and the influence this had on both regions. The system supports a project approach, although everything can be related so that historical analysis and comparisons can be performed. It is flexible, allowing drag and drop of data and information, including multimedia resources. This is a view of the live system, and the wallet containing various samples and documents was taken from a ship seized by the British Admiralty, which was trading between China and Holland at the beginning of the 1800s. The system, which uses a highly semantic form of linked data, is connected to the institutional archive system. It can search the TNA archive separately and import the data, transforming it as it's imported, and maintain synchronicity. Here we are searching the TNA discovery system and importing another archive object into the project. The system currently has a number of activities which will be expanded over time, including assessments covering context and significance. Here we're just looking at a new scientific analysis extension, producing consultation with the science team at TNA. It may be configured differently at different organisations, but the framework maintains the ability to integrate across different configurations. Here we are choosing the object that will be the subject of an analysis. Starting the analysis prompts a number of steps used to identify points or regions of the object and record measurements. Notice that the why questions that inform the work are an important part of the system, and other supporting information can be added to the analysis, including documents and archival materials. Techniques are often specific to different organisations with different equipment. Therefore, different configurations can be added and equipment parameters correctly recorded. Here we are adding the parameters to a procedure using TNA equipment. Using a customised version of IIIF, physical features can be recorded and are also translated into explicit semantic data. This region, a brocade textile incorporating metal, is the subject of XRF analysis. This is what is being measured. Data exported from the XRF system can be loaded into the system. The system also transforms the equipment readings to a semantic form, a type of dimension. The evaluation can then be completed. Again, other supporting files can be uploaded and bring all the elements together rather than scattered across different repositories. Not all the results are conclusive, so a belief system is used to store uncertain results, which are semantically typed as part of an argumentation ontology. The system uses frames so that different views can be seen on the same screen and data dragged and dropped between them. For example, regions identified by IIIF can be dragged to an image input on another screen. The data is stored in a semantic network which can be explored and extended using a contextual search and the knowledge maps we saw earlier. The existing data can be enriched in a canvas designed for subject experts to model new information and relationships which can be fully appreciated by others. If you'd like to learn more about the TNA project, which is part of a practitioner-researcher strategy to represent the daily work of subject experts as quality research, then please contact Sonia Schroll at the National Archives. Or if you want to discuss a knowledge base for your own organisation or project, then contact Cartography, the non-profit social enterprise that developed and maintains ResearchSpace and who work with the TNA to produce this system.